Hi, I'm Albertella. I work for Codethink and I'm the chair of the open source engineering process working group. So just to give you a little introduction about what our focus is. Um, so the idea here is to actually work out how we can develop processes that we can apply to working with open source tools and open source components, how we can use tools like the ones that Matt's just been talking about as part of a safety project, um, how we can develop safety analysis approaches that we can apply to Linux in particular, um, and so that those approaches can be applied and reproduced by others. Because although we're aiming to, as Philip was saying, as though we're aiming in Elisa to provide people with a set of tools and materials that they can use, we can't do the analysis for them. The analysis needs to be done on their systems specifically, but we can illustrate how we can do those analyses and apply that to Linux. We've also been thinking about processes for actually drafting and reviewing and publishing the results of the work that we do in Elisa. So how we get documentation that people can look at, can understand, and can have some idea about what thinking gone into it, what we were thinking about when we did a particular piece of work, and what sort of informed those results. We've historically focused on that safety analysis part because it's one of the things that's notably difficult when you're thinking about Linux. It's a very big and very complex piece of software. So thinking about how you apply safety analysis techniques to it can occupy a great deal of time, and we've had many happy discussions about it. But really, what we're thinking about here is what value can Linux add as part of a safety application? What is it that we're actually expecting it to do, and what are the risks involved in that, and how can we deal with those risks? But it's also about describing the kind of safety use cases that we might want to consider, and the role that Linux plays in them. And this is where the input from the sort of the groups like the automotive working group and the aerospace working group come in. If they've got a particular role that they want to, or particular use they want to put Linux to, then they can kind of describe some of those to us, and we can use those to inform what we're thinking about. And of course the goal here is can we actually kind of create things that are widely applicable, so it can be applied to more than one domain, but also that people can take and use in their projects, and learn from them, and kind of continue to find them useful, and that then we can kind of feed back that experience and make them more useful for other people, because that's one of the advantages of an open source project, is that you get to benefit from other people's use of the things. Our discussions in the weekly meetings are frequently more wide ranging than this. We do get into technical topics very frequently. We sort of talk about different methodologies. Mentioned STPA. That's one of the safety analysis techniques that we talk about. But also where quality fits into the picture. We talk about the various safety standards. So we do have some of our regular contributors have a lot of experience with the standards, so can answer questions about them, but also sort of general software engineering principles as well. So we're really thinking about the how of applying safety to Linux, and how that kind of feeds into the work that's happening in all the other working groups. So to talk about what we've been focusing on in the past year, um, one of them was this idea of how exactly do open source projects contribute towards safety arguments. So if you're wanting to use some open source software in your safety related system, what is it that you can benefit from what is it that you can benefit from that comes from an open source project. The open source project can't know about your system, can't kind of necessarily anticipate what you want it from. So what can they do to actually help you to do that? And so as part of this, we've been trying to work out how to identify and explore specific topics for Linux that are going to be of wide interest. And although it may seem a bit of a negative focus, this is often looking at what the design limitations of Linux are, or what characteristics of Linux are. I've called them unspecified or uncontrolled here, but really what I mean is that where it's the actual scope of what they do, or what their limitations are, or what you can and can't rely on isn't necessarily very clearly pinned down. And also there may be, in some cases, there's examples of that sort of fundamental aspects of the operating system that you can rely on for general use, but actually might have some issue if you're actually going to rely on it for some safety critical purpose. As part of this, we've also been looking at strategies for how you might identify one of these particular limitations, because it's not simply about, oh well, I want to make Linux better. I mean, obviously that's one of the things we could do. We can propose patches to the kernel to improve specific things we identify. But if it's actually about the overall design of Linux, and which is kind of fundamental to what it is, it's really hard for us to turn around to the kernel community and say, yeah, you need to change the design of Linux because it doesn't really work for us in a safety critical context. So quite often, although we can propose these things and they may make sense to the Linux community for other reasons, we can't always rely on doing that. So in many cases, addressing one of these limitations is about how we address that limitation in a system that's involving Linux, where we're integrating Linux into that system. And that means either are there ways we can configure Linux to prevent a particular problem from occurring? Can we rule it out? If we can't rule it out, can we detect when something's gone wrong? And if we can detect when something's gone wrong, can we react to it and actually deal with the consequences of it before it becomes a problem? And in some cases, you might need both. You might need a particular design change to Linux to enable us to do that kind of thing. But thinking about how we approach this problem is one of the things that we're particularly concerned with in this group. And there are some important factors to consider when you're kind of thinking about the feasibility of a given strategy. I've already talked about one, which is getting the Linux kernel to change to suit what we need is not necessarily going to be feasible. But we're also thinking about if we've got a particular solution that's already part of the kernel. So if you have some particular feature about managing security vulnerabilities that you want to use, then you might want to use that. You might want to use the mandatory access control features of Linux to control something. But actually, the complexity of the solution that you're using might actually make it more difficult for you to argue to make an argument about it. So in some cases, actually simply designing your system in such a way that, for example, users don't have access to the system that you're trying to protect, and therefore security on one level is less significant. It might be easier than having a very complicated set of configurations to manage that. The other thing to consider is the size of the target that you're trying to cover. So if you want to protect some aspect of the operating system or monitor some aspect of the operating system, if that's something that's happening in a lot of places, or if it's happening all the time, then your ability to monitor it might be limited. And then the other thing to consider is the kind of the size of the attacks, what we call the attack surface. If things can go wrong with the part of the kernel that you care about, how complicated is it going to be to analyze that and identify what kind of misbehaviors you might need to deal with? As Matt was saying, if you trace a system call through the kernel, you can very quickly see that it can go everywhere. So it's very easy for the set of things you need to consider, even for a relatively simple function, can quickly become a very large set of things to deal with. So in trying to kind of wrestle with these things, we've kind of, I think we've got to a point where we have a way to move forward to actually produce useful things here. And this is about this idea of being able to make things that are reusable and repeatable, so people can take what we've learnt, apply it to their system, confirm what we've said, and say, okay, so the conclusions that Elisa reached about this match what I'm seeing in my match the kind of behavior I'm seeing in my system. Therefore, I can build on what they've learned. So this is the idea of having repeatable research or repeatable investigations. An example of this was one of our contributors, Igor Stopper, talked about modeling a particular fault, a particular potential fault, to illustrate the fact that the kernel itself, if there's a flaw in the kernel, it could potentially corrupt memory that could cause a serious problem. And he kind of demonstrated this with a sort of a simple experiment to illustrate really the nature of the problem and kind of help us to explore its potential impact. So having that example of, here's an example of something that could go wrong, here's a way that you could actually illustrate that. So it's like a fault injection, as they describe it in hardware, or a fault induction, if you want to think of it as something that we're causing to happen at a software level. Then lets you explore, well, what really are the consequences of this, and if I have some protective measures that I've already identified, can they actually deal with this, and really show that that our method of dealing with this design limitation actually works. But it's not simply about this idea of an experimental proof. So although that's useful and that's a really good way to get people wrestling with it at a technical level to engage with it, it's also as simple as, if we're writing a document explaining how some aspect of the kernel works, then we actually want to document the sources of information we used in writing that document, point to where there are kernel docs about this, point to the code itself to say where you can kind of see this aspect of the designer Linux, where it is implemented, and understand it, so that, for example, if that changes in the future, you can go back and check what we wrote about it is still true. And we want to make this kind of, these two principles of being able to demonstrate something that you're making a claim about, or show where you've got the information to inform your document. We want to make this part of the review criteria that we use when we're actually saying, okay, we want to publish this material, put Elisa's name to it. How can we, how can you, as somebody reading and using that, how can you be confident that we've thought it through, and what have we thought through? So this brings me to the next piece, which is that we've also been thinking about, which is how do we go about publishing peer-reviewed material. So that's material that we've looked at, we've applied some criteria to. You can see who's reviewed it, because we're doing this in a GitHub repo, and you can look at the pull requests, you can look at the comments, you can see who's reviewed it, what their conclusions were. But then you can actually then see the document that's been produced for that, and understand why you might want to trust it. So we started applying this initially for just the material in the OSEP working group, but it's intended as a sort of a general approach for Elisa. And the principle here is to have the source code, if you like, for the documentation in Markdown in your Git repository, where you can control it and people can see it and comment on it. But then you want to turn that into something that that is easier to read, easier for people to interact with. And we're using a tool called MakeDocs, MKDocs for that to generate the content. And Philip was already talking about one of the kind of examples of that we've got, which is the directory site, which has a set of material from previous ELISA workshops there, and a way for you to find it. But we also have the OSEP one, where we're currently working to actually get some of our material that we already have in the repository peer reviewed and published there. And kind of to help that happen, we also want to establish what the process is for actually doing that, for submitting new material and for reviewing it are. So what we're planning for 2025 is really building on that. We want to get the existing material reviewed and published. We have some really interesting documents about, for example, interference scenarios in an ARM64 Linux system, and essentials about the memory management system that we'd like to get out there and have more people able to see it and give us feedback on it. We have some plans to write and publish some new material. First of all, the actual kind of review and publishing process that we're using for this documentation, so people can understand what we're doing there. But also, one of our regular contributors sort of identified that there isn't really any documentation he's found out there about how people in a supply chain for a safety critical system might actually be involved in consuming and analyzing and using open source software. So what kind of models are we thinking about when you're going to use open source software in your product or in whatever it is that you're doing? So writing about some examples of that so that we can be clear about what's shaping our thinking when we talk about these things. We also want to write some more about this OSEP approach and the objectives. Provide some sort of background and rationale for why we're taking this approach and what we've learned from previous attempts, and this idea of creating repeatable and reusable resources. But we're also always open to exploring new topics. So be really good to get some suggestions from people who want to join in. We'd like to collaborate with other parts of ELISA as well. So the architecture working group are planning to work on some kernel documentation for the tracing subsystem, which I'm sure Gab will talk about, and would be happy to help out with that. We'd like the other working groups to kind of use this document publication process so they can get their own little websites, sort of sub websites up with their documentation. The Zephyr project has done some work on functional safety, and it'd be really good to learn what they've done there and how we can apply that in ELISA. And also there's work happening in other open source communities. In the Eclipse Foundation, they're developing a process for working on safety systems where you're developing new software as open source, and developing a process that people can apply to that. And also joining the Eclipse Foundation is a trustable software framework, which is a project that I've been working on, which is thinking about how do you actually build up an argument about open source software, where rather than developing some software from scratch according to the kind of process you see in the safety standards, you're actually applying a set of standards to software that already exists and saying, why do I trust this, and how can I improve my trust in this, and why should somebody using it trust it? So I'm hoping that we'll be able to learn from these external projects, and as well as illustrating, providing things that they can learn from us. And how can you get involved? Well, we have meetings most weeks on a Thursday at 2 p.m. UK time. There's the OSEP calendar and the ELISA calendar that you can check for details of how to join that. You can also join the mailing list and write write your suggestions or write your questions there, and we'll be happy to engage with those. And also you can kind of see our regular meetings posted there. We'll be very happy for you to read and provide feedback on the documentation that we're producing in the OSEP GitHub repository. You can comment on the pull request that we have active, or create issues or pull requests with corrections to the content that we already have merged. And please, I'm very happy for you to propose topics for discussion. We can talk about them in the meetings. We can discuss them on the mailing list. And with that, do we have any questions?
There is one on the Q&A. Can you see it, Paul?
Yes, I can. So the ISO, I'm not familiar with 42001, but yeah, I'd be very happy to talk about that and what kind of relevance that might have. Please join one of the weekly calls, and we can or ask a particular question, raise that on the mailing list. Any more? Okay, excellent. Look forward to having you then, Karen.
Not, I'll stop the recording.
Okay,
Thank you, Paul.
thank you.